To be talking about reflections. Reflection is a flip or a mirror image of an object over a line. When we look in the mirror, what happens? We have a reversed image or a flipped image of what we're looking at. So when we are reflecting over the x-axis on the coordinate plane, we are looking for that mirror image or that reflection image. The x-axis is the horizontal axis on the coordinate plane. So first we need to identify the points of our original object. So point A, when we're identifying the points, we start at the origin. And for A, I'm going to go over -1 and up 4. So the point for A would be -1, 4. And we write it in a coordinate point. For B, I go back to the origin. Then I'm going to go over +5 and up +4. For C, starting at the origin, I'm going to go over +2 and up +2. And then for D, back to the origin, over -4, up +2. That is my original object, or my pre-image. In order to reflect over the x-axis, the object and the image should be the same distance from the x-axis. So if point A was 4 units above the x-axis, the reflected image would be 4 units below the x-axis on the same line. So my new reflected point would be -1, -4. For B, we go to the point here, it is 4 units above the x-axis, so the reflected image would be 4 units below the reflected image, so that point would be 5, -4. Point C was originally 2 points above the x-axis, so I'm going to go 2 points below the x-axis, and I get the point 2, -2. And for D, which was 2 points above the x-axis, I'm going to go 2 points below the x-axis. So that I get -4, -2. Now, what we notice here is we are looking at our points and comparing. How are they similar and how are they different? Well, what we notice is that the x-coordinate stays the same and the y-coordinate becomes opposite. So our rule or our pattern for a reflection over the x-axis is going to be, yes, there is a pattern. The y-coordinate changes signs to the opposite sign. And we're going to write the rule as x, y, that's our original point, goes to the image point as x, -y. Noticing that the y-coordinate changes. That's the important part here, that the y-coordinate changed. Now let's see what happens when we reflect over the y-axis. So first we need to identify our original points. If I'm finding point X, I'm going to go 7 units in the negative direction and 5 units up. So -7, 5 is going to be my first x value. For y, I go back to the origin. I'm going to go over to -2, up +8. And the last point, I'm going to go over -6, down -6. When I'm reflecting over the y-axis, I'm reflecting over my vertical axis, which means we're going to be going from left to right. Again, a mirror image needs to be symmetrical and exactly the same distance from your axis. So for point X, because that's our first point, if it was 7 units to the left, the mirror image would be 7 units to the right along the same line. So that means my x prime point is going to be from the origin, +7, +5. positive 7, positive 5. Now I need to find my y, which was 2 units to the left. So I move 2 units to the right, write my y prime, and that new coordinate, starting at the origin, was 2, 8. And the final point, z, was 6 units to the left. So I need to move 6 units to the right along the same line to get my z prime. And that point from the origin is positive 6, negative 6. And you can connect your points in order to draw the reflected image. Now we're going to look at these points again, and we are looking for similarities and differences. What we can see is that the y coordinate stayed the same this time because they stayed along that same y plane. What changed is our x values. We went from negative x values to positive x values. So the rule that we have for the y-axis reflection is that yes, there is a pattern, and when we are reflecting over the y-axis, the x coordinate changed signs to the opposite sign. And the rule to help you remember would be if you have your point and we're reflecting again over the y-axis, it's going to be the x coordinate that changes. Finish up this notes. We're going to look at some examples when we don't have the coordinate plane. But I do have the directions that for this original pre-image, I want to reflect over the x-axis. If you can remember that for a reflection over the x-axis, the y changes, then I know I'm going to look at each y value in my set of points and change it to its opposite sign. The x value stays exactly the same, so I'm going to have 3, and the negative 2 becomes a positive 2. The negative 1 stays the same, and in this case, 0 stays the same because there is no positive and negative 0. And then my last example, the negative 5 stays the same, but the 7 is going to change to a negative 7. So now I have my pre-image and the reflections, noticing that the y value has changed because it was a reflection over the x-axis. And our final example is a reflection over the y-axis. And hopefully we can remember that when we change over the y-axis, it's the x that changes. So I'm going to look at the x value for each of my coordinates. Keeping the y the same, I'm going to rewrite my new point, changing the x value to its opposite sign. So this first point becomes negative 3, negative 2. The second point becomes positive 1, 0. And the last point becomes positive 5, 7. Noticing that the x value changed and the y value stays the same. So in final conclusions, we have, if we are reflecting over the x-axis, the y value changes. If we're reflecting over the y-axis, the x value changes.